go and check the stream and tell me if the audio is okay?
Yeah, I got you.
Nice.
Nah, I'll do it. Fuck that, bro.
Okay.
I'll do it. God damn, I typed Blasm in Google, nothing came up.
Wow. I guess I don't show enough.
Stupid.
Unbelievable. I need to cancel Google.
Uh, yeah, let me know when you've checked the stream.
It's taking forever. Jesus.
Why is it taking so long?
Because my computer's a piece of shit.
Okay.
Oh, now there's an ad. Cool. Alright,
Oh
King, did you
no.
pull it up yet?
Should get an ad blocker, man.
Yeah, I just
Yeah,
pulled
I
it up.
do.
Yeah, it's on. It's working.
Okay, thank you.
The sound is good? Like the balance is okay?
Let me see. I gotta mute you guys.
Yeah, sorry. Darius, can you say something?
Something?
Alright. Can you say more stuff maybe?
Wait,
Um,
speak into your mic. Speak into your mic.
Yeah, we're talking. We're speaking.
Mashed
talking about-
potatoes.
Can you hear?
I can barely hear. I can barely hear Darius and Spellbreaker, and I cannot hear you at all.
Okay, I'm gonna turn myself up. Alright, what about now? Can you hear me? Testing.
Let's chip chungus.
Yeah, I can hear you, but you're still like super low.
I'm lower than them?
Yes.
Yeah, it's pretty low. I can hear.
Okay. What about now? I turned myself up a bunch. It could still be too low, but I don't know.
It's
I
better.
think like a little bit more.
A little bit more? Okay.
Still bit low.
Alright, what about now?
What is almost that?
It's perfect.
It's perfect? Okay, great.
I love it.
Alright. Okay, so I'm gonna assume that you know like the rules of poker, and you know no strategy. So I'm gonna talk about two things. First thing I'm gonna talk about is I'm gonna talk about ranges, and the second thing I'm gonna talk about are odds. So let's talk about ranges. So if you go and you play some hand of poker, so say the action, say you're playing heads up poker and you're the small blind or whatever, the small blind raises, and then the big blind 3 bets, which is just a re-raise, and then the small blind 4 bets, and then the big blind shoves, which means goes all in. Right? Just like a normal game of heads up poker. Now, let me ask you a question that doesn't really make sense. You're going to feel that it doesn't make sense. Say I ask you, what does the big blind have? And what do you think the big blind has? This is a question for all of you.
Mashed potatoes.
Mashed potatoes. All right.
Good
Okay.
start.
Okay. But actually, though, can someone give me like what do they think the big blind has?
Maybe he has like a 2 pair.
2 pair, sure. Well, this is pre-flop, and he only has 2 cards, so I think you should find a different game if he has 2 pair. But
He
has good.
Get his cards real quick. I think he has 7 of diamonds and like a 2 of spades.
Sure, 7 of diamonds, 2 of spades. So, okay. But like you can feel maybe that like this question doesn't like really make sense, right? Because, and I mean, I think this is why I'm sort of getting joke answers, right? Is that like he could have a lot of things here, right? There's not like one thing he's guaranteed to have. Really, the right question to ask is, what are all the things he could have? So he definitely has 7 of diamonds, 2 of spades, maybe, because he's like, some joker. But like, what else could he have, right? So like, he could have aces, right?
I was just thinking that.
Sure, but like, and I mean, he definitely could, right? Aces are a very likely hand. But he could also have kings. He would do exactly the same thing if he was dealt king king, right? And he could also have ace king suited, and maybe he could do this with queen queen. And okay, so there are a lot of things he could have, right? And the point is that asking what does he have, like what specific hand does he have, isn't the right question to ask. The right question to ask is, what is the set of hands you could have? What is the collection of hands you could have? And so the idea is that, so this is like the fundamental idea in poker, and where instead of thinking about individual hands, you think about what's called a range. So this is called a range, right? This is whenever you list all the possible hands they could have, you're saying this is the player's range at this point. And you want to answer this kind of question, like what do they have in terms of ranges? So let's actually try and write down like a serious range for the big blind here. So let's try and list every single hand we think that the big blind could have in this situation. So aces, kings, queens probably. Do you think they could have jacks? It doesn't matter if you give the right or wrong answer. It's just like I just want to like get a complete answer, Sure, you could probably have jacks. Do you think you could have tens?
Yep, definitely.
Okay. What about nines?
No.
All right, so let's stop it at tens then. So you could have ace king suited. Could you have ace queen suited?
No.
Okay, we'll just say ace king suited then. What about ace king offsuit? You could probably have that. What about, well, okay, if he didn't have ace queen suited, he's not gonna have ace queen offsuit. What other hands could he have? If do you think?
That sets up for a straight, maybe.
Sure. So can you name some specific combinations?
Like a 5 and a 6.
Sure. 6-5 suited, totally. Yeah. In fact, I mean, you could probably have like a whole collection of these, right? So what range, so these are called suited connectors. What range of suited connectors do you think you could have?
I wouldn't know how to say that.
Well, so, okay. He can have 6-5 suited. Can he have 7-6 suited?
Yes.
Yeah. So what about like 8-7? What about 9-8? What about 10-9? What about Jack 10, etc.?
All of those.
Okay. So Queen Jack?
Yeah.
Sure. King Queen?
Yeah.
Okay. So, and you can have Ace King. So maybe we can just say Ace King off, and then you can have Ace King suited down to 6-5 suited. All right. Sure. So maybe, so this is some range you could have, and then what about some bluffs? Do you think he has any bluffs in here?
They're bluffing.
Sorry?
Do we think they're bluffing?
That he's got any bluffs? Like things that are bad and he's just shoving because he wants you to fold?
He might have 7 and 2. He's definitely.
Sure, yeah, okay. So maybe he's got like 7-2 off, just complete junk, just trying to get you to fold. Personally, when I'm in this spot, I like doing this with ace-5 suited. I feel like that's a reasonable bluff in this case. Anyway, so, okay, so let's say this is his range. Let's say whenever a big blind has exactly this sequence of plays, then he's going to have exactly one of these hands. And now, you can weight some of this, right? You can say, maybe he's less likely to have ace-5 suited. Maybe you're saying, oh man, that's not what to do. Maybe you want to say that like he's less likely to have some of these, but pretty bad with paint, huh?
Hang in there, champ.
Why is this not working? What? Why can't I? Oh my god, why can't I select the fucking black? Am I crazy?
The color
I
one.
thought you just did. Oh, there we go.
It's great.
Right, it's weird. All right. Yeah.
Now it worked.
Okay. Anyway, so maybe we'll say has ace five suited 50% of the time. You don't have to have every hand the same frequency in your range, but it's just a complete list of all the things they could have. And so whenever you're thinking about hands, you really want to be thinking in terms of ranges. Like this is the fundamental thing to talk about, because if you can imagine that if you're the small blind in the situation, you might at first be overwhelmed when it comes to trying to make decisions about like whether or not you should call the shove. But if you had like a full list like this of all the hands you could be facing, then suddenly making decisions is a lot easier. So that's like the general idea of ranges. So let's do another example. Let's say you're the small blind, and you raise, and then big blind calls, and then the board comes, let's say, Jack of spades, 9 of spades, 8 of clubs, and big blind checks, and small blind bets, and then big blind shoves, whatever, 3 times pot, something like this. And maybe just to sort of help, not be too overwhelming, I'm going to say you're the small blind and you have, say, ace of diamonds, jack of hearts. I need this. Right, so I think your actions make sense. And let me ask you, at this point, when the big blind shoves, what do you think their range is?
So did they triple the pot size in bet?
I'm sorry, what?
So did they like add a lot of bet to the pile?
Yeah, like they it's just saying that it's a shove, and it's a big shove.
Alright.
But I mean, it's not like ginormous, but
Bring a straight.
yeah. So a straight is a good one. So they could totally have queen 10. They could have, I guess, 10-7. In fact, I mean, suited, not suited. What else could they have?
Well, if they had the fucking straight, why did he check?
Maybe he's trying to trap you. I think that I don't think he's going to check every time, but I think checking is what he does most of the time here.
So why checking at a straight? Just to fuck with him?
There are good strategic reasons to check almost everything in big blind spot here. So it's yeah, basically just to fuck with you is a good way to put it. Yeah.
Okay, alright.
But yeah, what else can you have, right? I mean, are these the only 2 hands you could possibly have after the shove?
No.
Okay, so what else could you have?
2 pair.
Sure, you could have 2 pair. So just gonna write 2 pair. Any 2 pair, I think, happens.
Yeah, full house.
Full house is illegal. There's no way you could have a full house here. Because he only has 2 cards.
He only has 2 cards, I think. Then he can't.
Yeah, it's impossible to have a full house without there being a pair on the board.
True. Very true.
What else could you have?
Crap, and he's bluffing.
Sure.
He's doing a crazy bluff.
Sure. Do you want to like guess specific hands that he could be bluffing with, or you just want to say like, bluff X% of the time? 7-2. Sure. 7-2. 7-2 off. All right.
You have 2 aces.
Yeah, you could totally have 2 aces. That's a great point. What else could you have? Like if he can have aces, can he have kings?
Yes.
Okay, how low can it go?
Probably to the 8, right?
Sure. So you're saying you can have all the way down,
Well,
yeah.
then, yeah. But I guess that also includes the 3 in a row. The 3 big 9.
Yeah, yeah. But so do you think you would shove here with tens?
No.
Okay, so yeah, so he's got ace ace
I skipped.
to,
Yeah, I
to,
skipped
to
it.
jack jack, and then he could have 9 9 8 8, right? But he can't have tens.
Right.
So if he has tens, doesn't shove here. All right. Is there anything else we want to add to this range? I'm just gonna move the bluff to the end.
Actually, I don't know. Like if you have if you have 10s, like what are the odds you get a fucking I forget what it's called.
A straight?
Yeah, it's still 2 more cards, right? So
I mean, yeah, it's pretty good. You're about 40% to hit a straight if you have tens.
I would say 10s in that case.
Okay, sure. That's totally reasonable. All right, what else? Well, so one thing I would point out is maybe this person has a bunch of draws, you know? Like if you had like a ace 10 of spades, I think you could totally shove here, right? Because you see ace 10 of spades, any spade gives you the best hand, and any queen and any 7 gives you the best hand.
So that's like the same odds as the straight, right?
Yeah, I mean, they're both 40%, so hitting one of them is very likely.
Yeah, that one too.
Sure, so, you know, we can do ace 10 suited, so maybe we'll just say straight draws, flush draws, right? Both of those make sense. You know, maybe we want to restrict, we want to say good flush draws, right? I don't think you'd necessarily shove with like, you know, 2 3 of spades, but ace 10 of spades, yeah, you know, or like ace king of spades, you know. So something like this. So I mean, here are some, you know. So I mean, here really, if you're doing this properly, you'd want to write down exactly what flush draws. But anyway, so I have some objections to this range. So the first objection is 10-7. So one thing about the range is saying, okay, these are all the possible hands the big blind could have in this situation. If the big blind had 10-7, we need to make sure that every single decision they made along the way makes sense. So would they call this bet pre-flop if they had 10-7 as their hand?
Well, it depends on the suit, right?
Sure, you know, sure. Maybe you can argue that like suited they would still call, but I would say no. I would say 10-7, you know, especially offsuit. You probably don't call this pre-flop, right? You probably fold it. So
What means before the cards come on the table?
yeah, exactly. So
Yeah, you wouldn't go blind with 10-7.
yeah, so even though, you know, sure, if you like magically had 10-7 at this decision point, shoving makes sense. It's really hard to even get here with 10-7 as your hand because 10-7 probably folds right here. So I don't think 10-7 is actually part of your range. All right. So what about, so let's look at some other ones. So I mean, do all the 2 pairs make sense? Sure, right? Jack 8, it's borderline, but you could probably call Jack 8, and then Jack 9 you're probably calling, 9-8 you're calling, okay. So you can still have 2 pairs. What about aces through 8s? Well, would you ever end up here with aces, really? I mean, sometimes, but not very often, because if you actually had aces as your hand, would you call here? Does that make sense? Well, I mean, over here, you said, oh yeah, the person could definitely have aces. And look, over here, they 3-bet with aces when they were facing a raise. But then over here, you're like, oh yeah, they could totally have aces. And they called facing a raise. So which is it, right? So this, I mean, yeah, in practice, right, the opponent will have some amount of aces that decided to just call here as like a trick, but it's pretty unlikely, you know? So what you can do is you can say, you know, maybe your aces are like, whatever, maybe 20% or something. It's, you're not doing it super often with aces. So you can have aces, but most of the time the aces raise pre-flop instead of calling.
Okay.
So you got to make sure. So the takeaway is that you have to, when something is in the range, you have to make sure that it makes sense at every step. Right? So does this make sense? That like, because, you know, if you magically materialize, you know, like warped into existence right here with some of these hands, like, yeah, sure, you would totally shove. But if you look at the entire history of the hand, then suddenly some of these hands stop making a ton of sense.
Right.
So this is an important takeaway. You can't see ghosts, right? If you've ruled out a hand at some point early on because of the action, it doesn't suddenly reappear in the range, right? Once a hand leaves the range, it never comes back later in the hand. It's gone.
Right.
Okay. So that's ranges, and you got to think in terms of ranges, right? Every time someone takes an action, you don't think, oh, what hand do they have? You think, what is their range? And you got to get good at writing down a specific range. And I mean, okay, you know, these ranges, you can debate some aspects of it, but like it's more or less like you're seeing there's a variety of things they could have, right? They could have the straights, they could have straight draws, they could have flushes, or flush draws rather, and then they can have like stuff like 2-pair, they can have over pairs, they can have sets, and they can have total bluffs, right? There are a lot of things they could have in this situation.
So how many pairs is like a range normally, like on average?
Oh, I mean, it depends, right? Like after this raise, your range is like 85% of hands you could be dealt or something, right? It's massive. It's almost anything. But then at the end of a long hand, ranges can be like really small, right? Because basically at every decision point, you know, depending on all the different things that could happen, you're kind of like splitting your range in half, right? Like, you know, when the big blind calls here, they're more or less splitting the range in half, right? Half the hands they're dealt are calls or raises, and half the hands they're dealt are folds, more or less. I mean, like, it's not actually half, don't take me too seriously, but like more or less it cuts the range in half. And then, okay, well, they check with everything here. But, and then this bet, this again, more or less, very roughly cuts your range in half. And then this shove, I mean, this shove like really is pretty special. Like this is a very weird shove. But, you know, in general, every like meaningful decision they make where they could have done something else, that kind of cuts the range in half. And you imagine if you take anything and you cut it in half like 10 times, you're not left with very much. So ranges can get pretty narrow by the end of a hand. And, you know, a lot of poker is trying to make sure that your range doesn't get too narrow, because if your range is too narrow, it's pretty easy to beat you. All right, so that's a review of ranges. Let's talk about odds. So for odds, let me put you in the following situation. Pot is $100. and say opponent bets $50, and you can either call or fold. Those are your only two options. Maybe because it's an all-in bet, maybe because you know there's no reason to ever raise for strategic reasons, whatever. You call or fold, and then the hand is over. So in this situation, my question is, how often you have to have the best hand for calling to be profitable on average.
Do you want a percentage?
Yeah, a percentage.
I'm just gonna go out on a limb and say never.
You can totally just guess a number, yeah.
70.
60%.
Sorry, what'd you say, King?
I said 70.
70? Okay. So 70%. Let's look at what happens if you have the best hand 70% of the time. So what's going to happen is 70% of the time, let me do it this way. 70%, you have the best hand. And then what happens when you have the best hand? How much money do you win when you have the best hand?
100.
Yeah, well, you win actually 150, right? The pot is 100 and then your opponent's bet. So you win $150. So how much is that on average? Well, you just multiply 70% of it. Well, maybe I'll do that a bit later. Okay, and then 30% of the time, you have the worst hand. And what happens, how much do you lose when you have the worst hand?
It's the same as opponent bet.
I'm sorry, what?
Is it 50? The same as opponent bet?
Yeah, you lose $50 when you have the worst hand. Because you had to put in $50 to do this. So let's say you're in this situation 10 times. So if you do this 10 times, what's going to happen? It's going to be 7 times you win $150, and then 3 times you lose $50. So how much does that add up to? 7 times 150 is 1,050, and then you're going to subtract 3 times 50, so you're going to get plus $900, right?
That's pretty good.
Yeah, and then this was if you did it 10 times. So what that means is that on average, how much would you win? Yeah, on average, you're going to win $90 if you call here.
Wait, why is the average?
You can bring the percentage down and still stay positive.
The average is 90 because you see if you did it 10 times, you would win 900. So if you did it once, you would win 90.
Wow.
So one way you could have done that is you could have multiplied the percentage by this amount. So if you get out a calculator or something, you're going to see that 70% times 150 is 105, sorry. And 30% times minus 50 is minus 15. So if you add these up, you end up getting 90, which is exactly what you did if you thought of this in terms of like doing it 10 times. So conceptually, I think it's a lot easier to think about it. Oh, just imagine yourself doing it many times. But if you want to actually just calculate, you can also just multiply the percentages. So whichever you're most comfortable with, you can use either. They're the same. Just if you do it this way, make sure you divide at the end by the number of times you've done it. So, okay. I asked how often do you have to have the best hand for calling to be profitable on average. So if you have the best hand 70% of the time, you make a lot of money. So certainly if you have the best hand 70% of the time, it is profitable to call, but you could have the best hand less often and it would still be profitable to call. So 70% was too high of an answer. So 70 is not the right answer to this question. 70 is like already very profitable. So it's the correct answer is lower. So what about another guess?
40%? Would that be too low?
What was your guess? Sorry?
40%?
40%? Let's
That
try
might
it.
be too low.
So let's do the same kind of calculation. So let's do 40% times, and again, you win 150 every time you have the best hand because you're winning your opponent's bet plus the pot. And the 60% of the time you have the worst hand, you lose $50. So 40 times 40% of 150 is going to be 60, and 60% of 50 is going to be 30. So this is going to total out to, maybe I'll write this out. Right. So this totals out to $30.
Lower.
So you're still very profitable if you have the best hand 40% of the time. But it's important to get in practice doing this calculation. So remember, so this calculation really, this is, so you have, the way I think about it is outcome 1 is this, right, when you have the best hand, and then outcome 2 is this, where you have the worst hand. So you list all the outcomes that you could possibly have, and then for each outcome, you say the probability of it happening times the payout for each outcome. And then what you do is you multiply the probability times the payout, and then you add up for each possible outcome. And that's the sum that you're doing. So it's important to be able to do this calculation, because this calculation happens a lot.
Wait, is this the same calculation if there's like 6 people?
Yeah, it's always going to be, no matter what, whenever you have like decisions to make, you're gonna compare those decisions by saying, okay, you know, what are all the things that could happen if I make the first decision, and how likely are they to happen, and how much would I win or lose in that situation, and then okay, what about the second decision, and so on, and you do that kind of thing. So for each outcome of the thing you're considering. So what are all the things that could happen, how likely are they to happen, and how good or bad is it for me? And then you multiply, and then you add up, and you do this no matter what. This is always the calculation that you're doing. Okay, so 40% still too high. Gonna do one more guess, and then I'm gonna give you the answer. I'm gonna show you how to.
35.
Well, 45 is 40 is already too high, so 45 is 35. Okay, let's do 35. So, all right. So Darius, I'm gonna put you on the spot. What's the calculation? What numbers am I multiplying and adding up?
Multiplying
Sure. So in this specific case, what's the percentage that I'm going to write down here, and what am I going to multiply it by?
Yeah, so the good outcome is what, 35% times 50.
That's right.
That one is oh Jesus, 65.
That's right.
Yeah.
Times.
Yeah, negative.
Yeah, -50, right? And just reminder, this number comes from the amount your opponent bet plus the pot, right? It's like you're going to win their bet and the pot. And this amount is going to be just the amount you had to pay for the bet. And okay, so if you do 35% times 150, I mean, you're going to get 52.5, right? And if you do 65% times 50, you're going to get 37 point. That doesn't seem right. No, 32.5, right? Yeah. And so if you add these up, you see you're still pretty clearly positive, right? You're still $20 in the plus.
So in this scenario, it's better to bet less often.
Well, so the question here is how often do you need to have the best hand to call? And if you had the best hand 35% of the time, it would be correct to call. You can go even lower. You might start seeing like a hint, right? That 40% it was $30. At 35% it was $20. Maybe that tells you when it's going to hit zero. Maybe not. Okay. Well, let's do some algebra, right? Let's say you have the best hand X% of the time. Oh man, maybe let's do Y% because I have an X right here. Is that okay? I hope that's okay. Y% of the time, you win $150, and 100 minus Y% of the time, you lose $50. Does that make sense?
What's Y again?
Y is a variable, and we're going to solve for it.
Why not? What's the variable?
It's the correct percentage to... It's the percentage of the time that you need to have the best hand for it to be break-even to call.
Sure.
So, all right, so here, we can't do anything great, so we're just going to write 150Y. And, okay, well, there's a percent at the end, but don't be mad. And then here we're going to do 100, well, we're just going to write it as 50 times 100 minus Y. And we want the sum of these two things to be 0. So when we add them up, what do we get? Well, we get 150y from the first term, and then we get minus 50y from the second term, and then we get plus 50 times 100 from the from this thing, right? So let's simplify this a little bit. So maybe I will just delete all these spaces because it's going to be annoying to reproduce them every time. So this is 100y, the first two terms, and then plus is going to be 5,000. And we want this to equal 0. So how are we going to make it equal 0?
What happened to PEMDAS? So you're supposed to do PEMDAS. So you're supposed to do like, so you're supposed to multiply in first.
Oh, I fucked up. Hold on. So it's a minus 50. So this is plus 50. This is minus. My bad. Makes much more sense. All right. So sorry. What were you asking, Darius?
So you're supposed to like multiply first.
Yeah. So we did, right? If you have the best hand some amount of the time, and you win $150, then that product is this, right? 150
Right,
times
but, the equation at the bottom.
one.
I think Darius is confused because they're on opposite sides.
Probably.
So, yeah, what do you mean when you say I should multiply first?
Like the 50 times 100.
Yeah, so 50 times 100, that's 5,000.
Oh, okay. Alright. Honestly, I just didn't even do it in my head. You just did the other one first.
Sure, yeah. Okay, so
Alright.
so what we want to do is want to know when we were trying to get this thing to be 0. That would have been perfect, right? Because then we know that's the break-even point. So what we're really asking is 200y minus 5,000 equals 0. So how are we going to make that happen? Well, I mean, we can move the 5,000 to the other side. We get 200 y equals 5,000. And then we can divide both sides by 200. Y is 5,000 over 200. So y is 25. And of course,
25%.
yeah, yeah. Yeah.
Oh, that's nutty.
And so this is what I was hinting at over here. You could maybe have guessed because 40% gave you a $30 payoff. When you subtracted 5%, your payoff went down by $10. So if you had done 30%, you would have gotten a $10 payoff here, and if you had done 25%, you would have gotten $0 here. Anyway. Oh, sorry, I didn't hear you. Yeah, so this is how you do the calculation in general. Is you just you do some algebra, right? You say, let this be the thing, and then you're done. But this is you can do this a bunch of times over and over again, and you'll sort of see the trick eventually. But the one way you can do it quickly is you can say, if you look at this ratio of 150 to 50, right? That's the amount that you would win if you won, and this is the amount that you would lose if you lost. Well, I mean, let's simplify this ratio a bit. 3 to 1, and a 3 to 1 ratio, for a 3 to 1 bet to be profitable, you need to win 1 over 3 plus 1 amount of the time, right? You need to win 1 time for every 3 times you lose. And if you're winning 1 time every 3 times you lose, that means you're winning 1 time out of 4 overall. Maybe I'll write out those intermediate steps. Okay. Does that make sense?
Yeah, these are all just the same thing, right?
Yeah, I mean, absolutely. But you can see that this gives you a shortcut. So for example, let me ask you the same question, but with different numbers, and we'll see if you can use this trick to answer it quickly instead of having to do the algebra. So let's say the pot is, let's say $40, and opponent bets $30, and then all right, so this is the same question, but with different numbers. So can you use this reasoning to answer this question without doing any calculation?
I don't think so. Because if you divide 40 by 30, it's not giving you a good ratio, right?
I mean, that would be fine, but that's not the right answer, right? Because, I mean, 30 divided by 40 is 75% of the time. You don't need to be good here 75% of the time to call. So what's the correct calculation?
That's what you're doing with the 150, right? And 50 is
Well, you see here in the denominator, I added it up, right? So if you follow the logic, it's you win 3 units whenever you win, and you lose 1 unit every time you lose. So it's a 3-to-1 payout. So you need to win 1 time for every 3 times you lose. But so that means you need to win 1 time for every 4 overall. 4 here is 1 plus 3. So it's 1 over 3 plus 1. So what would that be in this case?
what was the Y again?
Haha. That's the percentage. That's the amount of the time you have the best hand.
My time you have the best hand.
Isn't it? You need to win 4 times every 3 times you lose. You want the,
So
ratio?
so I mean that's a good start. That you said you have to win 4 times for every 3 times you lose, right? But actually, this is not quite right. This is wrong.
It's the other way around, right?
Yeah, it is the other way around. You need to win 3 times for every 4 times you lose. Because whenever you win $40. Well, actually, it's still wrong, right?
No, it's 7.
Yeah, that's right. It's 7, right?
7 every 3.
Yeah, so when you win $70, and when you lose 30.
Yeah, you have to win 7 times for every 3 times you lose.
Yeah, so this statement is correct.
No, it's the other way. Switch the numbers.
You have to win. So you're saying it should be a 7 here and a 3 here?
Yeah.
So, okay. So why is this?
Because you win 70 when you win, and then you lose 30 when you lose.
Okay. So
30 ratio.
sure. So let's work that out. So let's say you do this 10 times, right? Because that's sort of an even amount. So let's say you run this 10 times. You're saying you have to win 7 times, right? 7 wins.
Sure, yeah.
And then how much are you winning every time you win?
70.
Okay, so that totals $490. And then your 3 losses, how much do you lose every time you lose?
30.
Okay. So that totals a loss of minus $90. So when you add these up, you get plus 400, right? Which is very positive. It's much bigger than 0. This means you're winning $40 on average. So
it is the other way around.
it is the other way around. Yeah, you see. So if you had done it the other way around, you're going to type exactly the same thing. If you do 7 wins times $30, well, let's not even write down what this is, and then 3 losses times minus, well, sorry, hold on. You have, okay, so 3 wins times $70 and 7 losses times minus $30. You don't even need to calculate, because what you see is that this is a 3 times a 7, and this is a 7 times a 3. So you know that they're going to cancel out. They're going to add up to 0. You don't even need to figure out the individual sums.
Maybe it's a little confusing because I'm looking at the pictures, but aren't the numbers switched in the first ratio compared to this one right here?
Sorry.
It's 150 to 50, right? And then it reduced down to 3 to 1, and this is 70 to 30, and it reduced down to 3 to 7. That like the numbers switched around. Visually, it's not clicking.
Um.
Does that make sense?
Sorry. So you're saying okay, when 150 to 50 became
Yeah.
3 to 1,
3 to 1. Yeah.
and here we have 70 to 30
And then it became 3 to 7.
became 3 to
Does that
7.
make sense?
I think this still would become 7 to 3, but then you see later on, step is 1 over 3 plus 1.
Oh, you have to put it to
Yeah,
okay.
and you see here it's becoming 3 over 7 plus 3.
Okay. Now it makes sense visually. Yeah.
Great. But yeah, the key insight is that the reason that it's this ratio, I mean, you can think of it using this logic. I think that will make sense to some people. But if you also just run the calculation, you say 3 times 7 minus 7 times 3, that has to be 0. You don't even need to know what the individual things are. That's why this like ratio thing works as a shortcut. But of course, the ultimate way to understand it is just like this, right? This is completely generic. This is like sort of no thinking, no cleverness, just like hit it with your big hammer of algebra, and it's got to be this,
Hit
right?
it with your algebra hammer.
Yeah. So this is a very important calculation that you're going to need to do over and over again. And remember that the key way to think about it is you write down outcome 1, and you do Bob times payout, and then outcome 2, Bob times payout, and then maybe you'll have more outcomes, but probably not, but maybe in the future, if we get to some more advanced stuff, you'll have more payouts, or more outcomes, and then you just add up. And so this is the key way that you're gonna like do all of these kinds of averages. Basically, it's a weighted average.
Gotcha.
Yeah.
So,
So
isn't this only relevant if you actually know how many rounds you're gonna be playing?
yeah, I mean this kind of calculation is sort of the building block for all of the more interesting strategic conversations. So you need to be able to make to do this calculation a lot, and then once you can do it, then we're gonna start seeing places that you need to do it. But it's very important to be able to do this, to go forward. So I mean, I'll talk about like a new topic as well, and then I'll show you where this comes up. But let me do one more question about odds. So, what numbers do I choose? Let's say you have the best hand 14% of the time, and let's say that the opponent bets $22 into a pot of 81. Should you call or fold?
Well, I mean, it's fold, right?
Why is it fold?
Because you're only winning 14% of the time.
Okay, well, I mean, what if it was $12 into a pot of 81? It sounds like your reasoning doesn't depend on the actual amounts that were bet.
Yeah, I guess not.
So, yeah, you got to show me some reasoning.
This is the same formula as last time. It seems like drastically different than the last one.
Well, I mean, you should use this kind of thinking, right? Sure. So, and how often does that happen?
14% of the time.
Yeah, that's right. So you see you're doing probability times payout.
Yeah.
And okay, this is more or less $14, right? It's 14 point a little bit.
Yeah, and then
Yeah, if you want, it's like $14.5.
yeah. You lose $22. 86%.
Yeah, that's right. So 86%, you lose 22. And so how much money is that? That's going to be, looks like it's going to be like, I want to say $18. Okay. So if you add these up, well, you don't really need to add them up. All you need to know is that it's less than $0, right? And the reason that less than $0 is important is because if you fold, what happens? Fold, you just get $0, right?
Right.
So if you do this calculation, you can see that that you shouldn't call in this situation. There was another way to do it. If you thought about it in terms of ratios, you could say that you need to be good. So you win $103 when you win, and when you lose $22, right? So you need to be good 22 over 103 plus 22 amount of the time, right? And let me tell you real quick what that number is. 22 over 125 is 17.6. 17.6%.
So you're winning 17.6% of the time?
No, so this means the amount of the time you would need to have the best hand is 17.6%, right? So here you're again doing this ratio thinking, like over here we were talking about these ratios. It's the amount you stand to win and the amount you stand to lose. You do the how much you lose divided by the sum of the two, following this reasoning.
One more for good measure.
One more for good measure. Sure.
I get it. It's just this is actually kind of interesting, so I just want to know that.
Sure, absolutely. Okay, so I'm going to ask you the same question with different numbers. So
In French.
en français. So all right, let's say that you have the best hand all right. What's an interesting number? Let's say 38% of the time. Opponent bets $54 into a pot of 127. Should you call?
Okay, let's go the ratio route.
Okay.
Right, so you want to do 181
Mm-hmm.
to 54,
Mm-hmm.
and then so it comes out to at the end. Let's see, it's 54 over 181 plus 54.
Okay. And I can tell you what that number is. This number is 23%.
So yes, you call.
Yeah, this is an easy call.
Fire.
Cool. All right. So that's odds. So those were the two basic concepts I wanted to talk about. And I promised I'd talk about something a little bit more interesting at the end. So let me talk about So let me talk about what I'm going to say, polar versus, I'm going to pick like some pretty arcane name so that next time when I do something related, this name's gonna make more sense. So I can talk about a very common situation, a polar versus bluff catcher on the river. So what does this mean? This is a common situation where one player has either a really good hand or a really bad hand. And the other player always has an okay hand. So if we want to talk in terms of ranges, we're going to say, maybe this player has, maybe the range is like straight flush and 7 high, right? And the other player's range is second pair. So, and suppose this is like common knowledge. Both players understand that this is the situation that they're in. So they always know that one of the players has a mediocre hand and the other player has a really good hand or a really bad hand. Basically, you can think of this as like having a good hand and this is having a bluff and this is having a bad hand. So the terminology, the reason why this is called what it is that this is called polar and this is called bluff catcher. And the reason this is called polar is because it's like, you think of like, for example, the terminology of like polar opposites, right? It's like the extremes. And then the bluff catcher is because all your hand does is catch bluffs, right? It doesn't beat anything that isn't a bluff. So the fundamental question in this situation is how often should the polar player bluff? Right? Because, so let's talk, well, maybe we should talk about some obvious things, some obvious observations about the situation. So in this situation, the bluff catcher is never going to raise. Because if you raise as the bluff catcher, well, the polar player's life is really easy. They're going to fold their bad hand because they know that you have a better hand than them. And they're going to call you with their good hand, and they're just going to win every time, right? So as the bluff catcher, you should never, ever, ever raise, right? Your only options are call or fold. And then as the polar player, well, if you have a good hand, right, this is on the river, and you know it's been established, we just established, that this player, the bluff catching player, is never going to bet. So if you check, they're just going to check behind. So if you have a good hand, like a straight flush, you should always bet, right? There's no reason not to bet, because either they're going to fold and you win whatever's in the pot, or they're going to check and, if you bet, they're either going to fold and you're going to win what's in the pot, or they're going to call you and you're going to win what's in the pot plus a little bit extra. If you check, then they're always going to check behind and you're going to win what's in the pot because you always have a better hand. So it's just strictly better to bet when you have a good hand as the polar player in this situation. So the only decision points are, do you bet with your bad hand, and do you call facing a bet? So let me write that down to summarize. Does this make sense?
Yeah.
Yeah.
Okay. So maybe I'll do that instead of this. Okay. All right. So these are the two questions that we're going to try and answer. So we're going to have to give some percentages to this range. So I'm going to say that you have a straight flush with probability P, and you have 7 high with probability 1 minus P. So here P is a number between 0 and 1. You can think of it as, the percentage of the time you have a straight flush is 100p%. Okay. And so let's do this calculation that we did up here, right? So let's say the pot has, well, I don't want to use too many variables, I'll just write pot. What you want to, we're going to assume that P is small, right? Because P is the probability you have a straight flush, and it is pretty hard to have a straight flush. So we're going to assume that P is some small number. The math ends up being a little bit weird and not very interesting if P is big. If P is big, then basically the polar player always bets and the bluff catcher always folds. So it's not super interesting to look at that case. All right, so what happens when P is small? Well, if the polar player always bets, then because we're assuming that P is small, the bluff catcher should always call, right? Because some tiny amount of the time, yeah, they're going to lose to a straight flush, but most of the time they're gonna just bluff catch the bluff, right? And they're gonna make a lot of money. So say always bets with bad hand. Right? So yeah, you should just always call. The bluff catcher should always call if the polar player always bets. And then what about polar player never bets with a bad hand, then you should just always fold, right? Because if the polar player is never betting with the bad hand, they're only betting when they have a straight flush. So just fold, right? There's no, there's nothing complicated about that. So it's sort of this so these two things together tell you something. They tell you that you should bet sometimes, right? Not every time, but not never either. So some fraction of the time you should bet. So I'm going to say well, I don't want to maybe say X%. I want to say with probability X. And now what we're going to figure out is, sorry, I should probably pick Y because we're going to have some X's for when we do multiplication. And the question is, what should Y be? How often should they bet with their bad hand? Well, we're going to answer this question by doing the same kind of calculation we did up here. So facing a bet, let's compare the bluff catcher's options. So they can always fold, and that gives them $0. So now let's see what happens if they call. Well, what's going to happen is that we said with probability P, they the polar player has just a really good hand, right? So when that happens, they're going to lose the amount of money that the bet size was, right? And then it's probably, well, so how often is the bet that they're facing not a maybe I should do this in fewer steps. Sorry. Because the polar player is betting with probability Y when that's bad hand, it means that you have P bets with good hand, and then you have 1 minus P times Y bets with bad hand. So this is the ratio of the good hands to the bad hands. This is the amount of time that a bet from the polar player is a good hand, and this is the amount of time that a bet from the polar player is a bad hand. Because whenever they have a good hand, they're going to bet. So you could think of this as being like P times 1, and then whenever they have a bad hand, which happens probability 1 minus P, they're going to take Y% of them and bet with them anyway. So the amount of time that this is, so if the polar player bets and you're like facing that bet, then the amount of time that the fraction of the time that it's a good hand is just the P divided by the sum of the probabilities, and bad hand the rest of the time. Okay, great. So now let's go back to here. So if the bluff catcher calls, what's going to happen? Well, when we can do the good outcome first. We can do outcome 1, probability of it happening times the payout. So the good outcome is that the polar player has a bad hand. So that happens probability 1 minus p times y over p plus 1 minus p times y. And then times, well, let's just say this is going to be bet size plus pot size. And the bad outcome is when the polar player has a good hand. So that happens with this probability. And in this case, you lose just the bet size. So let's add these up. What do we get? Well, adding them up can be kind of gross. I fucked this up. Oh man. Well, so we could add these up and do the algebra, right? It's kind of gross. So I'll leave it for later. Let's do this ratio thing. So the ratio is 1 minus p y over p plus 1 minus p y to p over p plus 1 minus py. And you can see that this ratio, you can cancel out the denominators, right? A ratio of, say, 3/5 to 4/5 is the same as a ratio of 3 to 4. So you can get rid of this ratio. And the denominator of the ratio, and just 1 minus py to p is the ratio. And so what that means is that for the bluff catcher's call to be break even, bluff catcher needs to have the best hand and just like before, it was going to be p over and the sum, right? P plus 1 minus p. Yeah. Oh, with the pot sizes, huh? My bad. Sorry about that. It's this number times, I just write b plus p, right? And times b. So you need to have the best hand. P over P times P plus all right. So this is the amount of time you need to have the best hand to be able to call. And what you would like to do if you are the polar catcher is you want this number to be equal to 0. And you see, as the polar player, the only number in this entire formula you have control over is y, right? It's how often you bet when you have a bad hand. So let's take this formula and set it equal to 0 and then see what happens. Let's solve for y. All right, let's see what happens when you solve for y. or sorry, not quite. So this is the amount of time you need to have the best hand. But I mean, the amount that you win in general, I guess you're just gonna have to add these up, huh? So if you add up these amounts to get the amount you actually win, what you get is I'm going to put the denominator at the very end. And then the numerator is going to be 1 minus p times y times p plus p plus or minus p times b, right? Oh, I see. So as the polar player, you want to make it so that this quantity is equal to 0, right? Because that's when the bluff catcher is indifferent between their options, right? If you made this quantity just greater than 0 all the time, then the bluff catcher would happily call, and you're just giving away money. If you made it less than 0, then the bluff catcher would fold, and you'd be like, hey, I can just bet more often for free. And you know, every time you bet and your opponent folds, then you win the pot. So you want to be making your opponent fold as often as possible. So you want this number to be equal to 0. So this number, and then you have this denominator, which is just going to go away immediately. And so just multiply both sides by the denominator, you get 1 minus p y times b plus p minus p times b equals 0. Move the p times b to the other side, you get 1 minus p times y times b plus p equals p times b. And then you're solving for y, so you get, say, 1 minus p times y equals p times b over b plus p. And then y is p over 1 minus p times b over b plus p. Okay, so this is the key thing. So what this means is that, sure?
Okay, so what you were just doing, right? At the second step, I see where you got that from. You multiply both sides by the denominator. But you go over the third, fourth, fifth step one more time?
Sure. So here I'm taking this thing, and I'm just moving it to the other side.
Okay, alright, I got you.
And then in this step, I'm dividing both sides by this quantity.
Okay, alright. There you go.
And then, yeah, last step, I'm dividing both sides by this quantity.
Okay, I got you.
Yeah.
Thank you.
So, so you end up with this formula. So what does this mean? What this means is that so if the polar player bluffs with probability p over 1 minus p times b over b plus p whenever they have a bad hand, then bluff catcher's options, and these are call and fold, are both have an expected value of $0. Both give you $0 on average. And this is really important because if you bluff more often than that, then you get called every time and you lose money, right? Like the EV of the bluff catcher is strictly positive, and every dollar the bluff catcher's winning is a dollar that you, the polar player, are losing. So you don't want their EV to be very high. So you don't want their...
What's an EV?
EV is short for expected value. It means just the average amount of money you win. So if you bluff more than this frequency as the polar player, then you're giving the bluff catcher money. If you bluff less often than that, then they're going to fold every time. So you're not like losing money, but every time they fold, you win the pot. So you would like them to fold as often as possible. And remember, every time you check when you have a bad hand, they're going to check behind and they're going to win the pot. So you're missing an opportunity to bluff and make them fold. So I'm going to put it this way.
So doesn't that just mean you're supposed to bluff 50% of the time?
Well, I mean, you're supposed to bluff this amount of the time.
Yeah, don't you get it, Darius?
So, I mean, sure, like this calculation was technical. It had a lot of symbols in it. But the point is that when you look at all these crazy symbols, what am I really doing? I'm doing exactly what I did up here, right? Outcome 1, probability times payout. Outcome 2, probability times payout. Add them up. So, the probability times the payout, probability times the payout, add them up. So that was with like concrete numbers. What about down here? Well, it's the probability times the payout, the probability times the payout. It's kind of gross. It's a lot of symbols, but you see we're doing the same thing conceptually. So if you want to, I've written out all the algebra. You can go and look at it and you can follow it. But at the end of the day, conceptually, that's what you're doing. You're doing that same calculation that we did, many times above. And what you end up getting is that if the amount of time the frequency with which you bluff when you have a bad hand is exactly this, then the average amount that the bluff catcher wins when they call is 0.
Okay.
So,
All right, hang on.
Mhm.
So you play 10 rounds. Are you just like deciding this like from the start? Like how do you?
oh, like how do you actually figure this? Like in practice, say this number is like, whatever, 33%. How do you play like that? A lot of professional poker players, like you can go on Twitch, and you can watch like, Landon Tice, right? He's one of the he's one of one of the superstar poker players these days, like one of the big up and comers, and you can watch him play like online poker, and he literally has, I mean, not random.org, but basically random.org. He has a random number generator open, and when it comes to him, and he has a hand, like King 10 offsuit or something, and he needs to like, some of the time he's gonna call, some of the time he's gonna raise, or like some of the time he's gonna call, some of the time he's gonna fold. He will literally go to his random number generator, click it, a random number will pop out, and he will use that random number to decide what he's gonna do. And I mean, how he knows exactly like what percentage of the time he should do what, that's like him going on feel, or that's like him having studied a bunch and like, he can see some patterns, he's doing some calculations in his head. But yeah, at the end of the day, a lot of professional poker players will use a literal random number generator while they play the game to determine what action they should take. I got a question in chat that I didn't see for probably like forever because I was I was tabbed to a calculator. Are you changing your definition of bad hand relative to the button here? When I say bad hand, in the context of a polar versus bluff catcher, I really just mean anything that is worse than everything in the bluff catcher's range. So it doesn't matter exactly what the specifics are. So this little bit here, I mean, basically answers our one of our questions, right? This tells you how often the polar player should bluff when doing it, and you see that we figured this out by doing that same kind of calculation that we did in the odds section over and over again, but we just did it in general. So maybe we can do some example. Suppose the pot is $44. Well, let's maybe make some round numbers. That's not so crazy. Bet size is $50. Right, and the polar player has a good hand 20% of the time. How often should the polar player bluff with their bad hand to make the bluff catcher indifferent to calling?
You say indifferent, you mean like?
It means that calling is just as good as folding for them on average. And the reason that's desirable is for this reason. If you bluff more often than that, then the bluff catcher is just going to call you every time, and you're going to lose money on average. And if you bluff less often than that, then you're just leaving money on the table, right? You could be bluffing them and making them fold and just stealing the pot when you had no business winning it. So this is really what you should be aiming for. So yeah, so here's the question. Okay, well, so the answer is this number that we just calculated. This is exactly the answer to this question is the thing that we just calculated. So really, we just gotta take these concrete numbers and plug them into this formula. So the answer.
P is the polar player.
Yeah, P is the amount of time, is the percentage of the time that they have a good hand. So here it's 20%. So we can do 20 over 100 minus 20. Right. That's the first term. Actually, let me scoot over a little bit. Sorry.
20.
20 over 100 minus 20 times
50 over 100 plus 50.
I'm going to write it as 50 plus 100 just to be completely in parallel with the formula. Okay, so let's calculate what this number is. This is, so 2 over 8 is 1 over 4. And then this is sorry, 20 over 80.
Oh,
Yeah, it's 2 over 8, that's 1 over 4. And then 50 over 150 is 1 over 3. So it is 1/12 of the time.
Makes sense. Makes
Yeah.
perfect sense.
So this is 8.3%.
so if you have a shitty game, well, the range is like, but then like 1/12.
Exactly. And this is what a professional poker player would probably do in this case. If they were in exactly the situation, they would do this calculation. They would know this calculation. And do I have another chat? It was probably a very old message. I hadn't checked chat for like a while. Sorry. Yeah. So yeah, the professional poker player would do this calculation, or would know this calculation well enough, and then they would go to our literal random number generator, and they would generate a random number between 1 and 12, and on a 12 they would bluff, something like that.
Yeah, that makes a lot of sense. Because that's like the amount I would expect. Like that makes like sense. Well, in my head.
Yeah, I mean, it's totally reasonable to have a sense of this, right? Like, if you have a good hand only 20% of the time, and, from this calculation above, like, we did the 150 thing, right? We did, right? We did that specific example. And we found that if you have the best hand 25% of the time only, that's when you break even for calling. So in this situation, you have a good hand very rarely, and your opponent really doesn't need to be good very often to call you. So it makes sense that you would not bluff very often, because it's very easy for your opponent to call you. So the reason you're not bluffing very often is that this makes it so that when you do bet, it's more likely to be one of your good hands, because you're betting with your good hands every time. And so the way that you really want to think about this is that your good hands are like protecting your bad hands or something. And this is like a general something I'm going to talk about more in in future talks, where it's like, so let me write this down. So the idea is, when you have a good hand, that's what's causing your opponent to fold. You bet, and your opponent is inclined to fold because, like, oh, well, my opponent has a bunch of straight flushes, better fold. And then you're like, okay, well, if they're folding every time, then I can start sneaking in a few bluffs, right? A few bad hands. Like, the bad hands get carried by the good hands. It's like, if the good hands are like the tough guys, right? They're protecting you. And then you sort of like your bad hand, and you like come along for the ride. You're like, oh, can I bet too? And like you sort of steal the pot for free those few times because the good hands are so like intimidating. But the issue is that you have way more bad hands than you have good hands. So the good hands can't protect everybody. And so it's a question of like resource management, of like how often can your good hands, like how many bad hands can your good hands really protect? And in this case, they can protect 8.3% of your bad hands. And the other bad hands, they're shit out of luck. If they try and sneak in and steal the pot, they're just going to get beat up. So most of them have to just like check and give up and accept they're going to lose the pot. But like 1 out of 12 of them, they can be protected by the good hands, and so they can come in and get you a few extra pots. So Yeah, I mean that's absolutely an accurate analogy. So you can imagine if you're playing a fighting game or like any game where you have one move that's extremely threatening, your opponent has to play around that move every single time, basically, right? Like almost every single time. And so all your shitty options that they can't cover at the same time as covering your good move, those shitty options like get in for free, right? You get your free jabs in because your opponent is afraid of the throw. And it's like, well, how often can you jab before they actually just start protecting against the jab? And you're like, you're not going to throw me, you know? And it's like, the answer is you can get in a lot in that case, right? Like because your throw is so scary. But so like the actual numbers end up being a little bit different in a fighting game versus in poker. Where in poker it's usually the opposite. You need a lot of good hands to protect just a couple bad hands usually. Um, but the principle is the same. That you have this one big threatening thing that's causing your opponent to play in a certain way, and because they're playing in a certain way, like your other options kind of get carried by the fact that they're playing in that way.
So it seems like for the fighting game, you would want to like use like random data or something, right? It's like you can't actually do that. So it's like, how would you implement that then? Like in the middle of a fight.
Well, um, sometimes you gotta guess. There's like this. I want to call it a myth that humans aren't good at generating random numbers. One thing I've heard a couple times is, hey, there are these websites where they ask you to like generate random looking sequences of coin flips, and haha, humans can't do it. Computers always pick up when they're not random. I actually went and tried this. I went and looked for websites that prompted me to type in a sequence of random coin flips, and to see if like the computer could, whatever program they were running on the website, could discern between my input and an actual random thing. And you know what? It's all bullshit. The computer could not tell the difference between my input and random coin flips. So it's like, I don't know. I mean, I think it's just like a story that appealed to people to think, oh, humans can't produce random numbers. And certainly like Richard Garfield has some talks where he talks about like his 6-year-old kid being like unable to do this or something. But I think like if you practice and you're aware of like what random sequences look like, you can totally generate random sequences or random looking sequences. So in a fighting game, just try and mix it up. Just try and be unpredictable, and we're probably going to be okay at it. You can go onto one of these websites and practice if you want. But I really want to emphasize that the fighting game story and the poker story are not exactly the same. Because in the fighting game story, you have this one very threatening move, and that carries a lot of your bad moves. And that's the exact opposite as in poker. In poker, you need to have a lot of good hands to carry your handful of bad hands, right? Like, you needed, I mean, if you look at the total ratio, so this is saying that 8.3% of the time you're bluffing with a bad hand. So how many hands is that really? Well, you have a bad hand 80% of the time, and you're doing 8.3% of those. So how much is that? This is 6.6% of your hands. And this is versus 20% good hands. So really it's saying that you have 4 good hands for every 1 bad hand in your bets.
Wait, so isn't 4 to 1 like a different like ratio than like 6.6? Well, because hang on, so
Oh, did I mess this up?
no, I don't think.
I think, yeah, you're right. I messed it up. My bad. So what is the actual number? short. It's like something. It's not quite 4, right? It's closer to 3. Yeah, it's 3. Okay.
I think what I was actually talking about doesn't make any sense, but I'll take it.
Yeah. So you have 3 good hands for every 1 bad hand, right? Versus in a fighting game, you might have 3 jabs for every 1 throw. So it's the exact opposite. It's a similar calculation if you get into it, but yeah, it's yeah. So this is sort of the like how a lot of these calculations are going to go in the future, where you have control over how often you're gonna like make some play, how often you're gonna bluff, or how often you're gonna raise, or how often you're gonna call or something, and you can do that. So let's do, just to finish up, let's do quickly the other half of this, because we had 2 questions going into this, right? The first question was, how often does the polar player bet with bad hands? And the second question is, how often does the bluff catcher call a bet? So let's do this one really quickly. So say that the well, maybe I'll leave that for like the review next time, right? So that we can remind ourselves of how these calculations go. Or you can go and try and do it on your own, I guess, but probably won't. I never do when someone says do that. Yeah, but this, so we've answered this question, right? So the answer to this question was this amount. And then this, it's still outstanding. We'll do that calculation next time. And we'll see this very similar, and then we'll get into some more interesting stuff. But so, does this make sense? Like conceptually, does it make sense? I mean, even if you don't follow like all of the math exactly, do you understand like the main mathematical ideas? And like, you know, is the math to a point where it's not scary? Or like if you had to do it, you could?
Yeah.
Wait, it's just like logic, right? And it's like written down.
You know, Darius, I hate to tell you this, but math is just logic.
Well, yeah, it's like in fucking word form. Yeah, so
Yeah. It makes sense. I understand. So yeah, you did a good job explaining it.
as a wise man once said, let's do one more for good measure.
Facts.
Sure. So I'm just going to ask you the same thing, but with more complicated numbers, right?
Yep.
So, well, maybe, okay. Okay.
Can we get that formula?
Yeah, you can get that formula.
Yeah.
Yeah. Here you go. I'll copy paste it for you.
What the fuck
All right. So let's go. How often?
Okay, so it's 57%.
Mm-hmm.
Divided by 100 minus 57.
So I'm just gonna write 43.
Yeah.
Well, maybe I'll write. Sorry. Maybe I'll write.
43.
Sorry. What?
No, 21 divided by 21.43.
Okay.
So you know you fucked up, and the teacher's like, hey, excuse me.
Haha.
That's a wrong number. Yeah.
Okay. So I mean, I guess I'll just go and calculate this.
Yeah, 57 over 43 times 21 over 64.
Okay. Before spit out a number, do you guys want to guess what this number is roughly?
Guess? Yes. I'll be honest.
Really stupid.
I'll guess 21.
So this number
I guess 22.
is about 43%.
Alright, I win.
So you see here, you're bluffing a lot.
That makes
A little bit less than half the time.
All right. Let's. I want to do some more examples. So I actually want to. This is a good point. I want to show you some phenomena, right? Some things that can happen. So
that's weird.
let's say you have a good hand, 74%, and pot is 45, and bet is also 45. Then what?
Why is this? Does this give me that guy?
Mm-hmm.
Show you, Gary. You gotta go ahead.
Yeah, it's the same thing. So what happens?
Yeah, so 74 divided by I don't know how to say this, like 100 over the times.
Minus?
No, before that. Alright, anyway, yeah. 74. Yeah, minus 74.
Wait, isn't it 0?
Well, I mean,
Yes. No, wait, yeah, no, wait, this
No.
maybe minus 0.
Wait, continue. Don't mind me. I'm
Yeah,
thinking
yeah.
out loud.
all right. Let's keep going.
Yeah. 45, like times.
Sorry.
Yeah, times 45 divided by 45 times, plus 74.
Or is the
What'd you put before? No, it's 90.
why is it 54, Darius?
No, I said 74, didn't
Oh, this should be 74.
I? Yeah.
Why is it 74?
Wait. No, he wasn't actually.
Oh, so there's an uppercase P and there's a lowercase p. I know it's not the best. I'm sorry.
Oh, shit.
Uppercase P is the size of the pot.
Okay, yeah. Yeah, my bad. Sorry.
Yeah. I mean, you can think of it as like units, right? It doesn't make sense to add a dollar amount to a percentage. Dollar amounts should be added to other dollar amounts. So what should I be adding here? That's definitely not what I should be adding.
Well, at least that rules that out.
Yeah. So what should I be adding here?
You said it's just a pot, right?
Yeah, the size of the pot.
It was just 45.
That's right. Yeah, they're both 45. So this happens often, where the size of the pot and the size of the bet are the same number. Don't get confused.
Oh, okay.
Okay. And now how much is this? Anyone want to guess?
It's about a sixth,
It's that number he said.
right?
74 divided by 26 is not 1/6.
The other side is two, right?
It's 1/2.
Okay, yeah, 1/2. So 74 divided by 26, 1/2.
So if you plug this into a calculator, you get 142%. Yeah, so what does this mean? How do you interpret this number? Yeah. So one of the things I said at the very beginning was that we're going to assume that that P is small. So if P is big, then you get some weird behavior. And this is that weird behavior. So if you think about this, just like if you stop and think about the numbers here for a second, what's going on?
You could have 3/4 of the time.
Yeah, you have a good hand a lot. And
Crazy.
you know, your opponent, you can see just from the ratio stuff above that your opponent needs to be good 1/3 of the time to call this bet. Pot size bet. But they're not good 1/3 of the time. They're good about 1/4 of the time. So your opponent can actually just never call this bet, even if you bet with every single one of your hands. So in this case, you have a good hand so often, and just looking at the numbers, you can see that you have a good hand so often that you just bet every time, right? So one piece of advice I would have, just like of general mathematical advice, is always look at the numbers you're working with. Like don't get too bogged down in formulas. I had one professor who said that formulas or ideas go to die, and that's definitely true. Always look at the
General idea of the formula just by looking at the numbers.
yeah, just like try and like just don't blindly use the formula. Always like get the number and ask, does this make sense, right? Because what if you had typoed this and gotten 1.42%? You would know that's wrong. You'd know, wow, that's really way too small, given that I have a good hand so often, right? Like you got to look at the numbers and you got to ask yourself, like, does this make sense? And here, if you look at the numbers, you can say, wow, I have a good hand really often, and my opponent needs to be good 1/3 of the time to call. They're good 1/4 of the time if I bet every time. So this is what this is saying. Okay. Let me do one more example to show another thing that can happen. Let's say you have a good hand. Say 30% of the time. Pot is $50 and bet is $1,000. All right, what does that look like? 50 divided by what? Okay. 1,000 plus.
I think it's 50 plus 1,000.
Okay. And so if I plug this into a calculator, I get 2%.
Makes sense.
So you're supposed to bet 2% of the time.
This is saying you're supposed to bluff 2% of the time.
Bluff.
So does that make sense?
Yeah, shouldn't it?
No, this is wrong. That's what I'm saying. Think about it. It's like, okay. Put yourself in the position of the bluff catcher. Your opponent has a good hand, say 30% of the time. Not 30% of the time you're facing a bet, but just like whatever. They have 3 good hands in their, before they do anything. And then the pot is some small inconsequential amount, and then they bet a huge amount. How often do you as the bluff catcher need to have the best hand to be able to call their bet? So
That often?
one way you can think about it is if the size of the pot is irrelevant. Like let's just say, okay, let's say we take a deck of cards and we shuffle it up, and I deal you 1 card, and I take 1 card for myself. And then I say, hey, I'll bet you $100 that I have a higher card than you. I don't look at my card when I say this. Now you look at your card, and you see some card. How often do you think you need to have a higher card than me for you to say, yeah, sure, I'll take your bet of $100?
Do you want an exact percentage, or you just want like a majority of the time, minority of the time type answer?
Well, you can just say whatever you want to say. Like, I think you can give an exact percentage if you want, or you can just give a general impression.
I would say a lot of the time, a majority of the time.
So when you say a lot of the time, do you mean like a large majority of the time, or do you mean just like strict majority of the time?
A large majority.
Okay, so, So I would say that if you have an above average hand, or above average card, you should take my bet. Right? I haven't looked at my card. Maybe I should do it this way. I randomly give you a number between 0 and 10. And I randomly get a number between 0 and 10. And I don't look at my number. And I say, I'll bet you $100 that my number's bigger than your number. And now you can look at your number. And you look at your number, and it's a 6. Do you take my bet?
Yes.
Why?
Because I have a higher number than the vast majority of other available numbers.
Well, I don't know if 6 is higher than the vast majority of numbers between 0 and 10.
Yeah, my bad. Not vast majority, but then the majority.
Then the majority, yeah. On average, you're higher, right? You would accept this bet if you were dealt a 5.1, right?
Yeah.
Yeah, you just need to have an above average hand. So what we're saying is that when you have a bet at even odds, you stand to win as much as you stand to lose. You need to be above average. You need to win more than 50% of the time. So now let's look at this case this poker case. So the polar player bets, and the pot size is inconsequential, right? So the polar player is basically saying, "Hey, I bet you I have a better hand than you," and the pot size is inconsequential. So the bluff catcher just needs to be good more than half the time to call this bet, right?
Okay, yeah.
So if the polar player has a good hand, has 30 good hands, how many bluffs are they going to have to to balance those 30 good hands?
70.
I mean that they're going to actually bluff with. Like, how often are they going to want to bluff?
Oh, not that often, right?
Well, I would say they're going to bluff with 30 hands, just the exact same number as good hands they have. Because what that's going to do is that's going to make it so that the bluff catcher is 50-50 to have the best hand.
Run that by me one more time, because I did not catch that.
So if the polar player has 30 good hands, they're going to want to have 30 bluffs in their betting range as well. Because if they have 30 of each, that means the bluff catcher is 50-50 to have the best hand. And so they're indifferent between calling and folding, because the size of the pot is irrelevant. And they're going to call if they think they have an above average hand, and they're going to fold otherwise.
And that only applies in this situation because the pot is relevant.
Exactly, right? When the pot is very small relative to the size of the bet, the polar player is going to want to have the same number of bets as good hands. And all of that was done without really any calculation, right? It was all just, I mean, it's tricky, but there was no like algebra or anything. It was just like every step of the reasoning was like intuitive, you know?
Okay, that makes sense. Makes sense now. Okay.
So now let's look at this answer that we got. We got an answer of 2%. So we're saying that the polar player should bet 2% of the time with their bluffs. So basically this is saying they have like whatever 1.4 bluffs for their 30 good hands. That's pretty different from the 30 that we said they should have, right?
Yeah.
So what's up?
What is hold on.
Well, it has to do with how much the bet is, right?
Yeah, but like why are you getting the wrong answer is my question.
The formula's not right, right?
So what should it be?
Like the second half should be 1,000 over 1,000 plus
Yeah.
0.
Exactly. Just you mixed up the two numbers. This should have been
I'm
1,000.
legitimately curious. How did this start?
Darius asked me to teach poker.
And then
I mean, that's all I wanted.
Yeah. So okay, and so now if you plug this in, it's much more sensible.
Didn't know if Vladimir just appeared today. It was just like, we're gonna teach poker today.
It's about 40. It's about 41%, which is this makes sense because it's 41% of the 70% of bad hands you have. So 41% of 70% is about 30.
okay.
Oh, this is all because I fucked up the.
Yeah, it's because you got the formula wrong. But you see the message is that you got to think about the numbers, right? You got to ask like, does this make sense intuitively? And don't blindly use the formula, right? Formulas are where ideas go to die. And if you had just messed this up and been betting only 2% of your bluffs here, that would have been a horrible mistake strategically. Because in poker, this situation, being the polar player in this situation, this is one of the most profitable situations you can find yourself in. Like, when we go and we do the math at some point in the future, we're going to find that, man, like the bluff catcher in this situation, like they're losing a lot of money on average. Like they are very, very unhappy with their situation. And the polar player is like making a killing. So this is the single best situation to be in strategically in all of poker, I think. And it is so good because of this specific calculation. Because when you're in a situation where you can actually just bet as much as possible here, you make a huge amount. Basically what it means is, in our previous example, we saw that, you had 3 good hands for every 1 bad hand. So if you think about like the protection, right? Your good hands are protecting your bad hands. Here it took 3 good hands to protect 1 bad hand. So you could steal the pot once when you had no business winning it, every 3 good hands you had. But if you look at it over here, what's going on is that you have 1 good hand for every 1 bad hand. So your good hands are doing so much work. They're protecting so many bad hands, right? It's only a 1-to-1. You don't need 3 bodyguards. You only need 1 bodyguard. And so you get to steal a lot of pots. And so this is a really, really, really good situation to be in when you're the polar player. It's the most powerful situation you can be in. And if you had fucked up this calculation and put a 50 here instead of a 1,000, then it's you'd be paying for your bodyguards, but then the people you're guarding, the hands you're guarding, they aren't doing anything. They're not going and stealing those pots that they can go steal for free. And so you're missing out on a huge amount of money, right? You'd be missing out on winning a full pot about 30% of the time if you made this mistake in the formula. So it's really important that you think hey, does this answer make sense, right? Does this answer jive with my intuition? Is this what I was expecting? And I mean, okay, it's kind of unfair because I asked you this and you're like, oh yeah, sure, that makes sense. Maybe because you're spooked because this is such a big number, you're spooked because, I mean, seriously, when you play poker, who bets 20 times the pot? It's not very common. So, you don't really have an intuition for it. So it's kind of unfair, I know. But the point is you really gotta think about it. You can't just blindly rely on the formulas. The formulas are pretty complicated, lots of variables floating around, and all the variables kind of look the same. So it's kind of hard to know when you made a mistake. So make sure that you're double checking with your intuition constantly and asking hey, can I explain this behavior just in words in a way that makes sense to me? And the answer is almost always yes. So always try and do that in the same way that we did here, right? We explained why this number was bigger than 100%. We said, because we have a good hand a ton of the time. Of course, we can just bluff every single time and we're still good. So, just gotta, that's, it's important to think about it.
Yeah, Darius.
This thing's smart as shit.
All right, so I think that's that for. Mm-hmm.
So I've learned something.
Yep. So this is, I know this stuff is significantly harder than just ranges and odds, but hey, poker's a hard game. So, next time we'll do some practice for this stuff. We'll answer the other half of this question of, how often should the bluff catcher call a bet? And then we can start talking about polar versus bluff catcher, not just on the river, but in a full hand. And that's going to be like the archetypical poker hand, where you're if you understand that kind of poker hand, that's the most common type of hand you're actually going to play, and you're going to be able to use that as an anchor point. You can be able to actually go and play hands and be I sort of understand what's going on in this hand now because I have this template of this archetype, in my head, and I know how the calculations go for that archetype.
Then we can start betting money. I appreciate it, man. It was fun.
Yeah, this was fun. All right.
Shit. Yeah, I'm about to be a fucking poker star now.
All right, I'm gonna stop streaming by Twitch.